Hello, everyone, and thank you so much for joining us today. My name is Manjula, and I'm the Director of Operations and Community Relations at Indiaspora and your MC for today. And I'd now like to introduce James Abraham, the founder of Mynzo Carbon. James brings a wealth of experience and understanding of the energy sector and will be moderating the session on energy sector. Over to you, James.
Great. Thank you very much, Manjula. I have with me Tejpreet TP Chopra, who's joining in. He, after a long career at GE, decided to take the entrepreneurial plunge, and for the last 13 years now, I think, TP has been building Bharat Light and Power, and has just a fascinating story about his story through renewables. And we also have Srinivas Vishwanathan joining us. Srini, like the two of us, also gave up promising careers to jump into the renewable sector, and has, interestingly, a different path than what we had taken. So I think we've got three really interesting stories, all of us with more than a decade of experience in the renewable sector each, and has seen the arc of how this sector has developed and what the challenges and opportunities are going forward. The way we thought we would run this session is each of us will just take a few minutes telling you our stories. Each of us have very different parts of this story, although aligned. And then we'll spend a little bit of time talking about what the future looks like and then open it up to Q&A. I do have the Q&A box open, so if any of you want to write the Q&A in there, we'll bring it into our conversation. Let me start. We have, I think, 20 minutes or so. We'll all be, each of us will be very quick in our comments. Let me start off. I started my journey in solar in 2009. Back then, to give you some perspective, India had a total of 5 megawatts of solar in the country, in the entire country. And I remember someone telling me that you are giving up a good and promising career to go into what will always be only a marginal sector in this country. So just to give you a flavor for where the world started, not more than just 15 years ago. So it's amazing where we are today when we think about that we have now embarked on the transition rather than just being a marginal player. My first plant, our focus in this entire time was always on utility scale solar, selling into government PPAs. And our goal was, how do we build solar plants, renewable energy plants that could eventually become cheaper than coal? The idea was, can we make the economic pivot happen that allows transition to really take off? So in 2009, when we started our first plant, I signed my first PPA at a whole 12 rupees per kilowatt hour, which is astronomical compared to the 2 or 3 rupees at which power is being sold or exchanged in the market at that time. So almost 6 times. And then it took a long time. Our focus in the initial days was engineering, building up skill sets. Remember, when we only have 5 megawatts, we don't even have people who know how to build 100 megawatt size, thousands of acre sized plants, or even very large windmill plants. So there was a skill building process. There was an engineering process. So the first 4 or 5 years, our team was fully focused on engineering. And then we started a company called Solar Rise in 2014 that focused on financing. So we discovered that once we solved the engineering problem, the next thing was all about scale and financing. And in that process, by 16, 17, we were one of the first companies to sign a PPA below at that time, the going price of a new coal plant under 450. And that was exciting. That was a really pivotal moment. There was and I'm going to end my story there and just say there was an interesting narrative shift that happened in India at that time. Until then, the question was all about, why are we subsidizing renewables? There was always a budgetary discussion about the excess money going into these high-priced PPAs. In that moment, once we started to see pricing shift, the question started to shift to this idea of energy transition. It was no longer, why are we subsidizing? It's, we have to be careful how fast we switch over. And I plant that as a conversation we are going to have after we hear all of these stories. Just to close off my story, that part of the business, I focused completely on utility scale solar, selling into government PPAs and building up that relationship, and helped draft the first set of PPAs that then became standardized. And that business has been sold off and listed, which gives you an idea that there is actually economic value that can be released in the markets when people realize that this sector is actually a growing, economically viable, fundamental sector. And that's a story from being thought of as a very marginal, soon-to-be forgotten sector in 2009 to what has now become, in 15 years, a kind of central piece of our energy transition. TP, you have another arc to this story from the time you started. I know you have a slide to share and all of that, and there's a really strong element in TP's story around his focus around operations. Maybe that's part of your GE heritage. TP?
Thanks so much, James, and good to see you. And thanks to the Indiaspora guys for organizing this. I'll just quickly, my journey, James, now that you've mentioned your journey is actually very similar. As you know, I used to be at GE, and then after 15 years at GE, decided it was time to give back and do something different. And that's when I ended up setting up the BLP group to build, own, and operate wind and solar farms across India. And just like you mentioned, one of the big challenges we saw in our journey was, you were saying your first solar farm was 12 rupees a kilowatt hour. If I remember, my first solar farm was actually 18 rupees a kilowatt hour, and now it's about 2 rupees 20 a kilowatt hour. And my first wind farm was close to about 8 rupees, and that's today somewhere between 230 and 240 rupees a kilowatt hour. So as we saw this dramatic decline in the cost of energy, while the demand went up and while there was a huge expansion, I think one of the big challenges we saw was returns. Is that at the end of the day, one lesson learned I've had is that capital flows where the returns exist, because if there are no returns, you can't scale up. But that leads me to what I'd like to present, take about 3-4 minutes to present, is the fact that as this decline happened and as margins started getting squeezed, we just figured we've got to change the way we operate these wind farms and solar farms. So with that at back, I'm just going to quickly share my slides and just share with you 3 or 4 screens, just to give you a feel of how we thought about it in terms of what we need to do. So basically what we try to start thinking at James is that about 5-6 years ago, not only did we have the challenge of the cost of energy declining, but the second problem we had was that about 5-6 years ago, one day, one of my wind turbines burned down to ashes. So that's when I went to all our suppliers and said, to GE, Vestas, Siemens, Gamesa, Suzlon, and I said, guys, you guys maintain our turbines. We need to change the game if I can't have a situation where you are maintaining my turbines and I have a turbine burning down. So that's when we started thinking about how do we bring the physical world and the digital world together to really drive 3 things: drive productivity in energy production, 2, how do we reduce costs, and 3, quality and safety. Now, the reason this is critical is what we are seeing, James, is $650 billion going in unplanned downtime in manufacturing, wind turbines, solar farms, and industry still contribute to 30% of the global carbon footprint comes from industry. So in order to use technology and AI to really drive operations and efficiency, there are 3 critical things we need to do. First, we need to make these machines talk, right? Whether it's a wind farm or a solar farm. Then we clean the data, ingest the data, scale the data. Then we apply these algorithms and automate the process. But at a very, very high level, these are the things we need to do. Now, we don't make the sensors, but we get the sensors from GE, Schneider, Rockwell, Emerson. But we install these sensors or these cameras within the wind farm or the solar farm. And one of the big problems we have is GE never share data with Siemens. Siemens doesn't share data with ABB or Vestas. So we ended up creating this edge software, the second box that communicates to all the turbines, SCADA PLCs. We extract the data, clean the data, push it onto the cloud, and then we're able to provide these insights in order to create the industrial metaverse. But in order to create the industrial metaverse, there are 3 critical elements. One is the infrastructure. So you need a telco to get the data from a wind turbine in France, Germany, Spain, or Italy. Then we need to collect it. We need the physical world of sensors and robots, the digital world of AI, digital twin. But all these 3 elements have to come together to really change the way we do operations on turbines, and then be able to create a digital twin. I'll just talk to you a little bit about once we actually get all the data, then how do we actually use this data to really change the way we do O&M in wind and solar farms. And as that 18 rupees a kilowatt hour came down to 2 rupees, we started thinking about how do we use the use of technology to really change the way and reduce our cost of maintenance on wind and solar farms, and then started developing these AI algorithms to actually then predict failures in these machines so that we can significantly reduce the cost of O&M. I'm just going to very quickly show you some of these algorithms, whether it's in terms of predicting failures in components well before the component goes down in a wind turbine, whether it's about figuring out what the remaining life of these components are. And if we can do that, what we found was a significant reduction in O&M costs. Similarly, what we would do is actually see what the variations are from all these active power that we were actually seeing. And actually, these computers were able to track and predict when these turbines are going to fail. Similarly, on solar farms as well, we developed a whole bunch of algorithms for all the critical parts of a solar farm that can actually go wrong, and then actually created these algorithms to track when these PV systems are going to actually deteriorate, what the cabinet temperatures are for the inverters, and using these algorithms increase availability significantly. But now what we're doing, James, is pushing the envelope to use next generation technology to really change the way we use O&M for wind turbines. What we are seeing around the world, James, is close to about 10% losses. So about $2 million a year get lost due to lack of electrical and mechanical failures on wind turbines around the world. So when you really look at the wind turbines, the critical areas of the wind turbine that can go wrong, but the gearbox is one of the most critical areas. So as wind turbines on the chart on the left, as wind turbines have increased dramatically, but what you see on the chart on the right is only 50% of the wind turbines around the world achieve availability of higher than 97%. The other 50% is right on the left. And what we are finding is even a 1% improvement in reliability is worth about $2.5 to $5 million in additional cash flow for a 100 megawatt wind farm. But when we go down a little deeper, what you can see is if you look at the cost of energy, 25 to 30% of the cost of energy is O&M costs. And you break it down even further, 70% of that is really unplanned maintenance. But when you look at the right part of the screen, gearbox failure constitutes close to about 50% of the failures in all these wind turbines around the world. And therefore, what we're trying to see is if we use AI to predict these failures, we can actually significantly reduce the cost of a gearbox failure, which could be anything between $250,000 to $350,000, with just about $10,000 to actually repair these wind farms. So what we actually see around the world is close for up to 4 kilowatt turbines. We are seeing close to about 50% are bearing failures, and above that, startup failures. So what do we actually do? And let me just quickly end by showing you a few pictures. So our team actually installs all the sensors, cables connected to the PLCs. So this is an actual picture of a GE visor box, which is one of the world's most powerful high-frequency data edge devices. Normally from SCADA PLCs, we might get 20, 30 tags a second. But from this box, we can get 5,000 tags a second from up to 300 wind turbines. So we install the CDVD sensors in the generator, gearbox, motor bearings, and we start extracting the data. Step number 2 is we clean the data. Step number 3, we analyze the data. Now, when you really think about these rotating machines, we are getting high frequency data of temperature, vibration, electrical signature analysis. Temperature can give us a warning maybe a week in advance. Vibration, many weeks in advance. But when you combine the 3, the ability to predict these failures goes up dramatically. Why? When you think of any rotating machines, so these are the machines we used to make at GE, temperature would give you bearing temperature, static temperature. Vibration would give you bearing faults and mechanical faults. But now with electrical signature analysis, the quantum of data is so much greater that the ability to predict these failures goes up dramatically. So let me just end with this one last slide to show you the power of what we can do. When you look out here on the 20th of April, what you can see our negative sequence voltage is about 5% above the fault limit. And then immediately what we found is the earthing carbon brushes that failed. Fast forward to the 24th of August, negative sequence voltage hit 12% above the fault limit. Immediately the computer started sending out these alerts to the OEM, and we started telling him to shut down the turbine, otherwise you're gonna have a gearbox failure. As I mentioned, a gearbox could be $250,000 to $350,000. That doesn't include the cost of getting the crane, getting the nacelle down. So what could have cost you about $500,000, we could have fixed within $10,000 to $15,000, and the turbine starts operating normally again. So I'm just going to end there, James, but hopefully it gives you a little bit of a feel that given the huge decline in cost of energy production, and 2, we're using the technology, we can really change the game. Back to you, James.
Thank you, TP. As you can see here, we've had an engineering approach and then a very deep data science and analytical approach that been getting the most out of our plans to drive the economics down. Srini, I'm going to bring you in because from your earliest days, you've been working in a market where economics is absolutely essential. Can you just talk about how that market is unfolding, and especially given from 2011 to now?
Yeah, so thanks, Indiaspora, for inviting me and letting me share something on this. So what ever since I started, I mean I have worked in the U.S. market, in the Middle East market, and then transitioned to the India market. Even when I was working in the U.S. market, that time I used to work in a solar mezz financing startup where I was helping to fund more CNI. It was more development companies, residential rooftop, commercial rooftops, commercial utility scale plants. Back in the Middle East, also, I was working in the B2B business, kind of helping renewables on the B2B business. Of course, as you mentioned, we've seen in the 15 years to see the cost of energy on renewable energy range from almost $0.28 to dollar cents to now about 3.5, 4 cents. It's incredible cost of energy, and today we are already cheaper than fossil fuel. So the argument that we are on the marginal is no more there. And what I have seen over the beginning of this decade, last decade of 2011, 12, in India specifically, the cost of energy used to be close to 6-7 rupees, and especially when you're working in the B2B space where you're catering to the CNI market, the commercial and industrial market, the customer is very savings oriented. So they are not going to pay anything more than their grid tariff. They ultimately, at the end of the day, it's economics, bottom line. So as long as you're able to save money, that's what is important. We were on the threshold of waiting on subsidies, waiting on MNRE support in the early to 2011, 2012 to kind of show a business path in it. But post 2014, which at that time I used to be running the CNI business for Sun Edison, we were building some of the large CNI utility scale plants, and we saw a large adoption from the brave CNI customers to actually take the bait and support the growth of the CNI market. We did see some state programs that is coming in, but today where we are in a very different landscape. Today we are in a landscape where and now that I've been with Vibrant building the CNI platform, what we have today is a average a total portfolio that's under development and construction of close to 1.9 gigawatt. And we are seeing the CNI market essentially starting to become a major chunk of the Indian renewable energy market. And one of the things that today has happened is obviously the corporate sustainability commitments, companies becoming net zero, companies taking commitment of 100% renewable on their balance sheets have been huge drivers to kind of run that. But also at the same time today, because we are cheaper than fossil, we are actually providing incredible savings for the CNI developers, CNI customers. And the other angle today is we are trajectorying to a point in time today that we are starting to commit round-the-clock renewables on demand. And that's the game changer as I see, because if I am in a position where I'm able to build wind plants, solar plants, I'm able to use some of the tools that TP talked about on AI and modeling, internal modeling, to kind of figure out how I can deliver the almost a base load for my customer coming out of my wind and solar plant, maybe add some storage piece as well. I actually eliminate the need for a fossil plant completely. And that's going to be the game changer. And what's been amazing, and I think all three of us will agree here, when we make these predictions, we say, okay, in the next 3 years, we expect this to happen. And it's already starting to happen at the end of the year. So what I remember 2023, late 2022, 23 business plan, we had actually internally presented that this round-the-clock renewables will start happening in 26, 27. And as of today, there are contracts getting negotiated for round-the-clock renewables on demand in 2024. So I think the pivot is moving really fast. We are going to see a completely India. Also, there has been, not to say, I think we should give a lot of kudos to the government to opening up the segment, opening up the doing power market reforms, letting a lot more power being traded on open market, bringing more liquidity in the market, and all of those things. Now, with all those things that's happening, is we are actually starting to take a more nuanced view of how to deliver renewable power on demand. So I think that's the exciting time. And what we are today predicting that, in the next 3 to 5 years, storage costs will go down, and we will actually be significantly round the clock power. I do think we might be surprised with that trend coming even faster today in the next year or so.
Great, thank you. I know that we're down to just a few minutes, so I'll just wrap up with a quick comment for us to think about. As you can see in the arc from starting with 5 megawatts to where we are today, starting at 18 rupees to sub 3 rupees, starting at being a marginal player to becoming the core part of what we think energy will be like. It's really at a turning point, both with the data sciences, the engineering skills, and the market making skills that Srini has talked about. Now, Srini looks ahead as we look at the 24-hour power that we can now provide through renewables. The real question that we should all wrestle with is how quick can we make this transition? And I leave everyone with this word that we often hear now, the idea of a just transition. What does just transition really mean? And how do we take from the fossil fuel sector and shift here, and the consequences this country will face in that shift, both on the grid, populations? And I'm really reminded of Aarti's presentation in the morning. What happens to ecologies and the villages and the spaces in which this transition will have to occur? And I think that unfortunately today, the idea of just transition is a headwind to us. It's used to slow the transition down. Actually, when we look at much deeper, I challenge all of us to think of just transition as a way that can be actually more ecologically positive and economically and from a lifestyle perspective much better, and use the same approach to actually speed up this transition. So with that, thank you very much, TP. Thank you, Srini, and thank you to Indiaspora for hosting this important conversation. Manjula, back to you.
Thank you, James, Tejpreet, and Srini for your insights.